Hello everyone, welcome to this video. In this video, we are going to solve question again from December 2019 consisting of 4.75 marks. Let us see the question. The question is, let y is equal to y of x belongs to the class C for closed interval 0 to 1. That is the class consisting of fourth order derivative continuously differentiable, be an extremizing function of the functional iy, which is given to be integration from 0 to 1, second derivative square minus 2y dx, satisfying the conditions y at 0 is equal to 0 and y1 at 0 is again equal to 0. Then an extremal yx, if the extremal yx is given, satisfying the boundary conditions at the point 0 and 1, together with the natural boundary conditions, is given by which of these? So we need to tell what is the extremal to the given variational problem, right? So let us see. So let us solve this equation, right? So the Euler equation, this equation contains the second derivative, right? So what would be the Euler equation for higher order derivatives? So it would be, if this is my f, so it would be f of y minus d dx of fy dash plus d2 by dx2 of fy double dash is equal to 0, right? So what is f of y? It is minus 2 minus d dx of fy dash. There is no term containing y dash, so it would be 0 plus the second derivative with respect to x of fy double dash. So it would be 2y double dash is equal to 0. So this gives us, if I take 2 common, so this gives me minus 1 plus y raised to power 4 is equal to 0. So this is a fourth order ordinary differential equation, right? So how many boundary conditions you would require to solve this? So this would, solving this, we need to integrate it 4 times. So this would include 4 constants of integration, right? So we need 4 conditions, 4 boundary conditions. 2 of this are given in question, that is, we are given y at 0 is equal to 0 and y at 1 is equal to 0. Another conditions are the natural boundary conditions. What are these? Natural boundary conditions are those which are satisfied naturally by the solution. That is the meaning of this. Let us understand this concept using by an example. This is a support beam, right, whose one end at A is fixed and the other end, at another end, we are applying some kind of force or pressure onto it so that after a certain period of time it may bend, right? So here 2 kinds of boundary conditions are there. One is the essential or geometrical boundary conditions. What are those? Those are imposed on the displacement. That is, we are saying displacement at length x is equal to 0. This is the length x is equal to 0 and this is the length x is equal to L. We are saying that displacement in the vertical direction is 0 at these 2 points. So we are saying if the displacement is given by y, so it is 0 at x is equal to 0 and it is 0 at x is equal to L. The natural boundary condition associated with this is that the value of bending moment force in rotational direction, that is equal to 0. So the moment force is 0 at these 2 points. So this is the natural boundary condition in this case. So usually this is satisfied by this f given in the question, right? In certain other situations, we have the essential boundary conditions as the displacement and the natural boundary conditions as the force. So let us see the analogy. It says that for a differential equation of order 2n, the derivatives of dependent variable with order 0 to n minus 1, they are called the essential derivatives, and the associated boundary conditions are called essential boundary conditions. So the first n conditions are essential and the derivatives of order n to 2n minus 1 are called natural derivatives, and the associated conditions are known as natural boundary conditions. So in our question, we have a differential equation of order 4, right? So I can write this as 2 into 2. So n is equal to 2 in our case. So the essential conditions in our case would be 0 and 1, having the order 0 and 1, and the natural boundary conditions would have the order 2 and 3. But you see, in our question we are given the second order derivative here. So the natural boundary condition here would be that if this is f, so the derivative of f with respect to y double dash at the point 0 is equal to 0 at the left boundary, and at the right boundary f y double dash at the point 1 is equal to 0, right? So these four are the conditions that we would be using to solve this differential equation. So let us solve this differential equation. So we have y raised to power 4 minus 1 is equal to 0. Let us integrate this 4 times to see what would be obtained. We would have the third derivative of y is equal to x plus a. The second derivative is equal to x square by 2 plus ax plus b. The first derivative would be equal to x cube by 6 plus ax square by 2 plus bx plus c, and y is equal to x raised to power 4 by 24 plus ax raised to power 3 by 6 plus bx square by 2 plus cx plus d, right? So let us mark this equation as equation number 1. Now I'll apply the first boundary condition, which is given to be y at 0 is equal to 0, right? So this gives me directly d is equal to 0. So our equation reduces to y is equal to x raised to power 4 by 24. I can take common. So I'll have I'll take x by 24 common. So I'll have x cube plus 4ax square plus 12bx plus 24c, right? So now let me apply the second boundary condition, which is given to be y at 1 is equal to 0. So this gives me 0 is equal to 1 by 24 into 1 plus 4a plus 12b plus 24c, or this gives me simply 1 plus 4a plus 12b plus 24c is equal to 0, right? Mark this as equation number 2. Again, let us use the natural boundary conditions. What are those? Those are, we have to find the second the derivative of f with respect to y double dash at the point x is equal to 0, and the same at the point x is equal to 1. This is also equal to 0. So what was our f? Our f was y double dash square minus 2y, right? So this was our f. So what would be fy double dash? So it would be 2y double dash, right? So let us use this. So this thing, 2y double dash at the point x is equal to 0 is equal to 0, and again 2y double dash at the point x is equal to 1 is equal to 0. So what was our y double dash? It was this, x square by 2 plus ax plus b. So 2x square by 2 plus ax plus b at the point x is equal to 0 is equal to 0. If I substitute x is equal to 0, I'll have b is equal to 0, right? Moreover, here also I have 2 into x square by 2 plus ax plus b. And what was b? b is 0, right? So this at x is equal to 1 is equal to 0, right? So let me substitute x is equal to 1 into here. So I have 1 by 2 plus a is equal to 0. So this gives me a is equal to minus 1 by 2. So I have a, I have b, I have d. So now let me calculate c using this equation, right? So I have 1 plus or I can say 1 minus 4 by 2 plus 0 plus 24c is equal to 0. So this gives me c is equal to 1 by 24, right? So I have all the 4 constants. So what is our y? So our y is equal to x by 24 x cube plus 4a or it would be minus 2x square. B is 0 and what is c? C is 1 by 24. So our y ultimately is x by 24 x cube minus 2x square plus 1. So this is our y. Let us have a look at our options. So option C is the correct option. I hope you liked the video. Thanks for watching.